You know how in motorsports, two cars can get so close to each other the winner is decided by reviewing extremely short frames of footage? Well, imagine instead of two cars, two electrons are racing. If the same photo finish were to happen in the subatomic world, their difference wouldn't be a tenth of a second, but instead an attosecond. But what is an attosecond? An attosecond is 10 to the negative 18 seconds, or 1 billionth of a second. The attosecond is a unit of time used to describe the incredibly fast motions of electrons. Similar to a hummingbird's wings, we know electrons are there, but we can't track their exact motions by simple observation. Back in middle school, we learned to envision electrons orbiting a nucleus as a cloud, since they move so fast. However, with attosecond lasers, we can now observe these motions precisely. To understand how attosecond laser pulses are created, we can analyze last year's Nobel laureate's experimental setup. First, an ultra-fast laser pulse is split into two beams. The first beam is focused into a noble gas. The laser's electric fields cause electrons in the gas to be ripped away and then pulled back to their nuclei. Upon recollision, they emit radiation many times faster than the original pulse. These rays of radiation, called overtones, help control the laser's duration. How? Well, by stacking overtones, scientists can create these controlled square-ish waves. When the first beam recombines with the second, these overtones give us a controlled attosecond duration pulse through constructive and destructive interference. Researchers use an initial attosecond pulse to pump the electrons in motion, followed by another pulse to recapture their positions, creating an attosecond movie of sorts portraying electron dynamics. This is called the pump and probe method. How can this be used though? Well, attosecond lasers can orient molecular spins in magnetic materials, switching electrical properties within attoseconds. This could revolutionize computing, as semiconductors rely on ultra fast on off switches for calculations. The world of physics has forever changed, and the possibilities are endless with attosecond spectroscopy.